Right, the third way that we can solve simultaneous equations is via what we call elimination. So let's just do a little bit of pre-work here, a little bit of review. If I wanted to add these numbers, if I couldn't do it in my head, I could write out a little algorithm, something you would have learned in year 7 or 8, where you put one above the other, and I go through and I add 7 plus 2 gives me 9, 2 plus 3 gives me 59. So I can add two numbers together. I can do the same thing with equations. I can actually add or subtract equations to each other, and I'll do this by an algorithm. I'll put them lined up over the top of each other. First of all, I'll label them. I'll call the top one number 1 and the second one number 2, and I can add them together. So let's do that. I can start by adding my 5x to my 6x. 5x plus 6x gets me 11x. 2y plus negative y gives me y, because adding a negative is the same thing as subtracting. So I've basically got 2 take 1, leaves me 1y, and 7 plus 12 gives me 29. I've now added equation 1 to equation 2. So I can add them just like I was adding numbers using, like I said, what we call this algorithm. I could also do a subtraction. I could subtract 1 from 2. Let's do that. I'll rewrite them in an algorithm form, and I'll say, well, 5 take away 6x gives me negative x. 2y take away a negative y. Now, taking a negative, two negatives is a positive, so that becomes 3y equals 5. So I've added and subtracted. Now so as you can see, we're allowed to do that with equations. No problems whatsoever. This becomes really handy if adding or subtracting two equations gets rid of one of the terms. Because if I have a look here, I've got 4x's. If I subtract those 4x's, so in other words, if I add the negative, if I add these together, they'll cancel each other out. That's going to be really handy. Let's do it. 4x take away 4x leaves me with 0. If I add 3y to 2y, I get 5y. If I add 16 to 4, I get 20. You can see now that I've got 5y equals 20. There are no x's. Great, this allows me to work out what y actually is. Divide both sides by 5 here to get my y on its own, and I get a y value equal to 4. Can I work out the x value? Absolutely. I can substitute that value into one of the equations. I'll pick the top one, number 1 in this case. So wherever I see a y, I substitute the 4 to get 4x plus 12 equals 16. Now I just use my algebra skills to simplify that down until I get a value of x equals 1. And I have solved that. I could check that by substituting those values back into the equations to see that they're true. So if I substitute my x value of 1 and my y value of 4 into equation 1, I get 4 plus 12 equals 16, which is true. Let's check it against equation 2. Let's take these two values and substitute them into equation 2 to see if it holds true. Minus 4 times 1 plus 2 times my y value of 4 gives me minus 4 plus 8 equals 4, which is also true. So yes, I've checked them. I could also check them by graphing them using software, and I would see that those two lines, when I graphed them, would intersect at the point 1, 4. So that's how we use elimination, by adding or subtracting two equations together to help eliminate one of the variables.